Did you know that without radians and degrees, our GPS systems might have never found their way? Welcome to Unboxed Origins. I'm Howie, your resident science geek and accidental trivia sponge.
And I'm Wyatt. I ask the big questions. Sometimes philosophical, often skeptical, always curious.
Today, we're digging into how did radians and degrees shape the study of angles? All right, Wyatt, picture this. A circle. Simple, right? But how we measure this circle can take us on a journey through time and mathematics that's anything but simple. Let's start with degrees. The concept of dividing a circle into 360 parts dates back to the ancient Babylonians. They had a base 60 numeral system, which made 360 a wonderfully convenient number because it's easily divisible by so many smaller numbers. This division became crucial for early astronomy and navigation. Imagine sailors on the high seas plotting courses by the stars, all thanks to the Babylonians' nifty number crunching.
Ah, the Babylonians! Their love for the number 60 also gave us our hours and minutes. But tell me, Howie, how did radians come into play? They sound rather modern.
Great question, Wyatt. Radians were a bit of a late bloomer in mathematical history. It wasn't until the 18th century that they started to gain traction, thanks to the Swiss mathematician Roger Cotes. By defining an angle in terms of the radius of a circle, radians provided a natural, intrinsic way to measure angles that aligned perfectly with calculus and the emerging field of analysis. Unlike degrees, radians are dimensionless, which makes them incredibly useful in mathematical calculations and scientific equations.
So radians are like the unsung heroes of the mathematical world, quietly shaping the way we solve problems today. But if radians came later, why didn't they just replace degrees entirely?
Now we get to the heart of it. Degrees have stuck around because they're intuitive. Most people find it easier to think of a quarter turn as 90 degrees rather than pi over 2 radians. But in the realm of higher mathematics, radians are the stars of the show. They simplify equations in physics, engineering, and beyond. For instance, when you use trigonometric functions in calculus, they work seamlessly with radians, leading to more elegant solutions.
So, it's almost like degrees and radians each have their own realm of influence. Degrees in the everyday world and radians in the mathematical universe. But what's the aha moment here, Howie?
Here's the kicker, Wyatt. While degrees are tied to the geometry of the ancient world, radians are deeply woven into the fabric of modern mathematics and science. Think about the sine wave. It's fundamental in signal processing, sound engineering, and even quantum mechanics. The wave's natural properties only emerge when we measure angles in radians. This duality shows how two systems of measurement from different eras can coexist, each enhancing our understanding and application of mathematics in unique ways.
Aha! So, in a way, degrees and radians are like two languages describing the same universe. Each one gives us a different lens through which to view and solve problems.
Exactly, Wyatt. Radians and degrees together have shaped the way we understand and manipulate angles, allowing us to navigate both the physical and abstract worlds. It's a beautiful example of how different mathematical tools can complement each other, expanding our capabilities and understanding.
And in doing so, they remind us that the evolution of mathematical thought is a journey, one that continues to unfold with every problem we solve and every angle we measure.
If you enjoyed exploring the history of radians and degrees with us, don't forget to like, subscribe, and share the journey with others. Because without radians and degrees, who knows where we'd be, or if we even know how to find our way back.